Look up, go on, right now, wherever you are, look up. The sky is blue. It has always been blue. You have seen it every single day of your entire life, and I am willing to bet that you have never once stopped and asked why. Why blue? Why not purple? Why not green? Why not just completely transparent? Hi, I am Monty McLeaf. This morning I was lying on the branch outside my treehouse, staring up at the sky, and I realized I had absolutely no idea why it is blue. I have lived up in a tree my whole life. The sky is literally my ceiling. I see it every single day, and I had never once questioned it. So today I did, and what I found out is genuinely strange. Let me explain. Here is something that sounds simple, but is actually not. What color is sunlight? Most people would say white, or maybe yellow, but the real answer is all of them, every color at once. Sunlight is made up of the entire visible spectrum of color: red, orange, yellow, green, blue, indigo, violet, all of them, mixed together and traveling through space as one combined beam of light. They are all there. You just cannot see them separately because they arrive all at once and your eyes blend them together into what appears to be white or pale yellow. You can actually see this for yourself. If sunlight passes through a glass of water or a prism, a triangular piece of glass, the different colors separate and spread out into a rainbow. A prism does not add color to light, it reveals the color that was already there. A rainbow in the sky works exactly the same way. Each tiny water droplet in the air acts like a tiny prism. Sunlight enters, splits into its component colors, and sends them out in slightly different directions. You see the full spectrum spread across the sky. Red at the top, violet at the bottom. So light is secretly made of every color. That is the first thing to know. Now, when all that sunlight travels from the sun toward Earth, it eventually hits our atmosphere, the layer of air and gas that wraps around the planet, and this is where things get genuinely strange. Different colors of light do not all behave the same way when they travel through air. They travel as waves, and those waves have different sizes. Red light travels in long, slow, relaxed waves, like gentle ocean swells. Blue light travels in very short, fast, tight waves, like rapid ripples on a pond. And this difference in wave size matters enormously. When light waves travel through the atmosphere, they occasionally collide with tiny molecules, mainly nitrogen and oxygen. When a red light wave hits one of these molecules, it passes through fairly easily. The long wave just glides past. But when a blue light wave hits the same molecule, something very different happens. It bounces, it scatters, it shoots off in a completely random direction, up, down, sideways, at any angle, and then it hits another molecule and scatters again and again. Blue light is constantly bouncing around the entire atmosphere in every direction, all day long. This process is called Rayleigh scattering, named after an English scientist called Lord Rayleigh, who figured this out in the 1870s, which is an extremely impressive name for what is essentially just blue light being very, very bouncy. So here is why the sky is blue. When you look up, you are not looking directly at the sun. You are looking at the atmosphere surrounding it, and what fills that atmosphere from every direction is blue light. Blue light that has been scattered so many times in so many directions that it is now coming at your eyes from the entire sky dome at once. No matter which direction you look, left, right, up, you are catching blue light that was originally heading somewhere else entirely, but got knocked off course by all those atmospheric molecules and ended up pointing straight at you. The sky is not emitting blue light. It is reflecting it, redirecting it, filling every direction with it. Now, here is a question that you might have already thought of. If blue light scatters the most, why is the sky not violet? Because violet light actually has even shorter, tighter waves than blue. If short waves scatter more, violet should scatter even more than blue. The sky should look violet. And here's the thing, it does scatter more. Violet light is absolutely up there, bouncing around even more than blue. But your eyes do not see it. Human eyes have three types of color-sensitive cells, one for red, one for green, and one for blue. These cells are much more sensitive to blue light than to violet. When violet hits your eye, your blue sensitive cells pick it up, but your overall sensitivity to it is much lower. Blue simply registers far more strongly in your visual system than violet does. So the sky is simultaneously full of violet light that your eyes mostly cannot detect, and blue light that your eyes are very good at seeing. Your brain combines the signals and calls the whole thing blue. The sky is blue not just because of physics, but because of the specific biology of the human eye. If you had different eyes, you might see a different sky. Now, here is something that will change how you watch sunsets forever. At midday, the sun is almost directly overhead. Sunlight has to travel through a relatively thin slice of atmosphere to reach you, maybe 100 kilometers or so. Blue light scatters everywhere. The sky is blue. At sunset, the sun is near the horizon. This means sunlight has to travel through the atmosphere at a very shallow angle, a much longer journey. Instead of traveling through a thin slice, it now travels through an enormous thick wedge of atmosphere, sometimes many hundreds of kilometers worth. Over that long journey, almost all the blue and violet light has already scattered away. It bounced off molecules and flew off in every direction long before it reached you. By the time the sunlight arrives at your eyes, only the longer waves are left. The reds, the oranges, the pinks. That is what a sunset is. It is what remains after the blue has been used up. The sky is performing a slow color show throughout the entire day. Blue at noon when the path is short. Orange and red at dawn and dusk when the path is long. Purple and pink tones in between. Every color has a reason. Here is one more thing that I find genuinely fascinating. The sky on Mars is not blue. Mars has an atmosphere, but it is much thinner than Earth's and it contains a large amount of dust, fine reddish particles of iron oxide. On Mars, it is not gas molecules that scatter the light, but dust particles, and those dust particles are much larger than our gas molecules. Larger particles scatter red light more effectively than blue. The result is that on Mars, the sky is pinkish red during the day. And at sunset, which is the opposite of Earth, the sky turns blue. Mars has blue sunsets. On Earth, the physics that makes our sky blue makes our sunsets red. On Mars, the reverse is true. The sunsets are the blue ones. I think about this more than is probably normal. If this just made you see the sky differently, subscribe. There are 28 more things above your head that are worth looking at. I spent an embarrassingly long time lying on my branch thinking about all of this. At one point, a squirrel came and sat next to me and stared up too. I think it also had questions. I tried to explain Rayleigh scattering to it. It left before I finished. The sky is blue because sunlight contains every color. Blue light bounces around our atmosphere far more than any other color, and our eyes happen to be very good at detecting blue. Every direction you look, blue light from somewhere across the atmosphere is flying straight at your eyes. And at sunset, the blue runs out. What is left is red and orange and gold. Worth looking up at sometimes. Both of them. I am Monty McLeaf. I will see you next time.